Okie dokie, seems like I'm up and running. Get a full screen here. So these are problems 22 to somewhere in the 40 range, I think. I think I have time to get this done. I got about a half an hour. Again, this is just going to be the mechanics. And we can talk about why things work geometrically, numerically, analytically, graphically, tomorrow in class. Okay, we'll try to figure out what's best to move us forward. So I'm just going to go through it quickly. And if you got something wrong, you got something wrong, and hopefully at least you'll see the right mechanics. So this was about X and Y intercepts. We have a product here. So if we make that product 0, this one has to be negative 48/5, which is near negative 10. And then if this one's 0, we let Y equal 0, then we've got 24. Plot those 2 points, you got the line, and this is your 0 for X is your Y intercept, and 0 for Y is your X intercept. That's how you find X and Y intercepts. Factoring this was purely a recognition. You see, it starts with a square and it ends with a square, and I have a negative in the middle. Sure looks like 3a minus 5 squared is my answer. Yes, double that, minus 15 gets us that. All right, so this problem here, that could be a 0. That X could take on the value of 5/3. That X could take on the value of 2/9. And so those are your X answers. Boom, boom, boom. Minus 3x squared, we got a cup shape down. I think I was looking for a maximum here. Hope that's what it was, or it might be the roots. We'll do both. I don't know which is what. I'm going up at the y-intercept of -5, so therefore I now know minus b over 2a, minus b over 2a should get me positive 2. If I put a 2 in here, I get 24, which means over here should be -12. And it indeed is, so there's no mistakes. So that's 12 minus 5, which is 7. So 2, 7 is my maximum is 7. And my roots are, so I've got real roots because my zeros are here. Y equals 0 is bigger than -5. So I should have measuring from X equals 2. Oh, I'll start getting some eraser here work. Well, I got an eraser. All right. I can clean up this board a little bit. Since we already did that problem, that's done. And so now I can look at this and say, oh, measuring from 2, I got to go plus or minus in that direction to find that X. I got to go to the right from this X, and I got to go to the left to get to this X. All right, and I have to move down 7 units, and I'm dividing by a -3. So negative into a negative is a positive, and the inverse is squaring the square rooting, and those are my roots. Now I can erase this, because you can pause the video and go back and look at what I did, because I'm talking very quickly. So I've got 2 functions here, and I'm trying to find f of 8. So I've got my 2 functions, so I put an 8 in, and I evaluate that function for 8, and I can see that that's equal to 3, and then I put the 3 into the g function. Oh, I'm doing g of f, yes, g of f of 8. And so the g function is tripling whatever comes out of this function, and in this case, 3 comes out. So my answer should be 8. All right, now, this notation asks me to find the inverse of that. And if you're solving an equation, let's say we had a 2 = 3. Well, I could rearrange that to say 8 equals 2 to the 3. I said I wouldn't explain these things, but I guess I am. So what is the inverse of log base 2 of x? It's 2 to the x. And we use inverse operations to solve equations. So if we're going to solve a logarithm, we got to know that's its inverse. Okay, let's check it out. Over here, an 8 gets me a 3. Over here, a 3 gets me an 8. Okay, no mistakes, move on. Okay, so that takes care of that. That takes care of that. Let's hope that next problems are on this side. All right, problem 29. Let's make sure that board is correct. Yep, I'm okay. So understanding exponential growth or decay is all about differentials. And so this is a differential of 4 to 16 is 12. I have a differential of 4 to 8, which is 4, which is 1/3 of 12. And so I'm going to start at x equals minus 1900. So that should get me 16. We'll check it in a minute. And 2000 is 100 years later. And all of these differentials are on top of y value of 4. So that's that calculation. Let's just drop 1900 in. because many of you do need to still figure out 1/3 to the 0. All right, 19 minus 1900 gets me to 0. All right, and 1/3 to the 0 is 1, times 12 is 12, plus 4 is 16. And I'm sure the other one works as well, and it'll be easier to see. Put 2000 in, you see it works. Now I can work up above here. All right, so just like we did 2 problems ago, you rearrange this. X is equal to 5 to the negative 2, and I hope you know that that's equal to 1/25, 5 squared. Now, what are the understanding logs? You have to understand differentials, and the differentials are horizontal this time. And that differential is the first one, and that's 4, and this is 12. Sure looks like we're doing the inverse of the problem we had before on some level. It's a slightly different look. So I start with y. Well, what y do I see? I see 2000. How do I get from 2000 to 1900? I subtract 100. This is a logarithm, and logarithms have to be positive values here. And how do I get positive values? I better be bigger than 4. All right, and if I drop an 8 in, 8 minus 4 is 4. If I divide that by 4, I get 1, and log base b of 1 equals 0, regardless of the positive base. And that gets me 2000. Okay, and so I think I just have to get the base of this, and I get that base by dropping 16 in. 16 minus 4, 12 divided by 4. Oh, 3. Yeah, I guess I have it. Now, I also want to say at this stage that subtracting an exponent, if I have an exponent, okay, then it means that I could flip the base. So I could make this a plus, and I could make this 1/3, and both of those equations give me that graph. You can go check it out, put it in Desmos or something. So we got 2x to the 4th equals minus 29. I believe I'm correct there. So x is equal to the 4th root. No, so I forgot to say plus minus first myself. Even roots have plus minus answers. Odd roots do not. So what have I got? Minus 29 over 2. And I'll move the minus sign outside. And that should be your answer for that one. Okay, I think you can see that. Let's bring the next board in. Problem 32. So I'm looking for problem 33. Problem 33 is, oh, just a quick Pythagorean relationship. I'm only giving you first quadrant work at this stage. We'll work in other quadrants later, but that's an x distance, and this is a y. And I got a 5 to 7, so I'll try to draw it. There, if that's 5, that's not too bad. Okay, so what do I have? I've got, let's do it on a smaller level. Let's just do it without the axes this time. All right, so what do I have? I've got 49 units. I've got 25 units, not necessarily drawn to scale. It looks like I need 24. So what is this distance? Square root of 24, which you could leave like that for now, and you'll get a check from me like that. But we're also learning how to write that as the square root of 4 times the square root of 6, which is 2 root 6, which is approximately 2 times 1.41 times 1.73. All right, that's 2 times the square root of 2 times the square root of 3. I'm lecturing now, but I don't mean to. I just want to get correct answers. So root 24 or better, 2 root 6. Those are your answers for that. 0, 0 to 1, 4. I think we're doing the same thing here. That's an x change, and that's a y change. So what's our graph look like? Not our graph, but our picture. Our picture looks like I'm going over 1 and up 4. And I'm trying to find that distance. I hope you can see that that distance is the square root of 17 using the same analysis we did on the last problem. 16 and 1. The smaller sides add up to the bigger side. And I hope you can see what that distance is. All right. Or we're solving quadratics. More times than not, you set it to 0. Makes life easy. There's 3 ways I could solve this quadratic. I'll do all 3. The quickest way, perhaps, is seeing that that's easily factorable as x, 2 numbers that multiply out to negative 24 and add up to negative 10 are x minus 12 and x plus 2. So I hope you can see your answers here are 12. X could equal 12 or it could equal negative 2. We can put -2 in to make sure. So that's 4 plus 20 minus 24 equals 0. Okay, so we're in good shape there. Another way I could have done this. I could have done completing the square based on how it's written here. This is x minus 5 squared minus 25, which equals 24. So therefore, I bring 25 over, that's 49. I take plus minus square root, which is plus minus 7, and I add 5. What's 5 minus 7? -2. What's 5 plus 7? 12. That's another way I could have done it. Another way I could have done it, which is probably the holy grail of Algebra 1 classes, is the quadratic formula. X squared minus 10x minus 24 equals 0. I tend not to use it much anymore, but minus b, 10 plus or minus the square root of 100 minus 4, I use open parentheses. 1, that's what's in front of the x squared, minus 24, and that gets us 100 minus 96. I think that's the square root of 4. Hope I did that right. So this is 4 when you do it, which gets me 2. And I'm dividing by 2 times 1, and 10 minus 2, I think I made a mistake here, is 4, so I did make a mistake. Go back and do it out more carefully. What was it, 100 minus 4 times A times C minus 24, oh yeah, negative is addition. So I went way too fast. 80 and 16 is 96, so that's 196. I don't think that's is that 14 times 14? Probably 14 times 14. So what would this have been? This would have been 14 here plus minus b, 10 divided by 2. 10 plus 14 is 24 divided by 2 is 12. 10 minus 14, yes, so it should have been 196. I had made a quick sign error. All right, I think I'm done with that. Let's get the other side. Should be problem 36. And I am looking for 3 coordinates for this upside down parabola. I hope you can see that minus 9 times 25 times 0 is 0, which is the smallest thing you can get out of squaring. So it sure looks like if I put a 5 in, I get a 7 out. That's vertex form anyway. So that's immediately given. That's 1 coordinate. Then what do I want to divide by 25 by? 25. So this has to equal 25 for the next user-friendly number. Well, I think if you look at 10 and you look at 0, you're accomplishing that. And those are symmetric to the number 5. So 5 gets you 7, 10 gets you minus 9 plus 7, minus 9 plus 7 is -2, 0 gets you the same cancellation. So you're going to get the same answer. So there's your 3 coordinates. And we worked on that yesterday in class. And you'll see it for the next 4 tests. Or is it 5 tests? I'm not sure. But I want you coming out of this class being able to do that. All right, so now we're going to do some quick factoring. So what do 10 and 12 have in common? 2, it's got an M, and I got 15 and 9. So both of these have at least y times y times y 9 times. What do I multiply that by to get back to here? Well, I certainly need a 5, and I certainly need 6 more y values. All right, and what do I need to multiply here? I've got the my9, I've got the my9, so I just got to figure out what I have to multiply to get -12. -6. That problem's done. All right, you can always replay it. So if you want to understand exponentials, you have to understand differentials. I'm going up 5, and then I'm going up from 3 to 9, 6. So the base of my exponential is going to be 6 over 5. All right, I guess I'm just writing this equation. So y equals 3. How do I get to, I got to go up 5 units. Next time I don't go up 5 units, I go up 6. So it's a very slow exponential growth, but eventually it's going to take off like every other exponential function. All right, and now I got to make b to the 0, which is 1, and b to the 1, which is b. So I got to make a 0 and a 1 out of 1993. And I put a 1 in, I look at the differential there, in terms of time, 7 plus 24, 31. And that's how you do that. All right. Now, if you want to understand how to graph logs, then you got to know this. You got to know the log of 0, regardless of the base. You got to know the log base b of 1, and you got to know log base b of b. If you can make this parentheses equal these 3 values, you've got yourself a quick graph. So what makes a 0? In this case, 7. That becomes your asymptote. Exponential growth and decay backwards means not time to amount, but amount to time. And if you don't have any amounts that are greater than 0, you don't have anything that's growing or decaying. So I got to have at least 7, more than 7 units in this parentheses, or the calculation doesn't work. So now what makes this calculation 1? 2 times 1 is 2 plus 7 is 9. So a value of 9 should be easy to work with because that equals 0. So we made this equal 0 when I plug a 9 in. 0 times anything is 0, so that gets me at 4. All right, boom, boom. And then we got to do one more, b of b. So I got to get this thing to equal 4. 2 times 4 is 8. 8 plus 7 is 15. Okay, and we got some differentials. How far is it from 7 to 9? 2 units. How far is it from 7 to 15? 8 units. Oh, I think I have a base 4. Oh, yes, base 4 exponential backwards problem. So put a 15 in, we get this calculation, which is equal to 1. 1 times 5 is 5, plus 4 is 9. You practice that over the course of the next couple of weeks, and you can do these in 10 seconds or less. All right, so what's next? Next is f of x. We're trying to find the roots. All right, so if you want to do quadratic formula, you go right ahead. I'm not going to do quadratic formula, and I'm just going to put it in graphing form because that's easy to find the roots, and it's easier to put this in graphing form. So I've got 3, I've got x, I got a minus with a square. Minus, well, this is decreasing side. The decreasing side is on the left, so that's where my y-intercept is. That tells me that, which means that my x value is positive. And so therefore, 3 into 24 goes 8 cut in half. Minus b over 2a should have gotten me a 4. Okay, and then if I put a 0 in, I should get a 9 out. If I put a 0 in here right now, I get 48 out. 16 times 3 is 48. I don't want that 48. I want that 9. And now I'm solving for 0. So that's going to get me on the other side positive 39. Divide by 3. And then I'm going to do plus minus the square root. And I'm going to add 4. So on your answer key, I believe I had 4 plus or minus square root of 13. And we can show that. I've got time to do it, so I'll do it. 4 plus or minus the square root of 13. Let's do it out. Yeah, 4 doesn't work, right? Because we know that gets you a vertex down here, and that's not 0. Right? So we got rid of the 4s. Squaring the plus minus is just positive. Squaring the square root gets you what's inside. 3 times 13 is 39. 39 plus 9, correct me if I'm wrong, it's 48. 48 minus 48 is 0. If you want to do the quadratic formula, be my guest. All right, so I got more problems over here. All right, so I've got 20x cubed minus 5x squared. If I can write that as a product, I can see my answers. So I've got minus 5x squared equals 0. I think I can write that as a product pretty easily. I'll take minus 5x out, and I'll multiply 5x squared out. That's the greatest common factor. And I'll multiply by minus 4x plus 1. And that's equal to 0. I'm going to clean it up. I'm going to make this positive. I'm going to change the signs. And now I can see my answers more clearly. I've got a 0 and I've got a 1. All right, you play that again and slow me down. And I don't have much time. I'm going to give you any help at all on a video. I've got to do it at that speed. So I'm looking for m to the what? M to the what gives me m to the 6 over m to the 2 to the negative 2. I can simplify that to be one of these things. If I'm counting, then there's m to the 4. 6 minus 2 is one of the rules. And if I know my rules of exponents, then I guess x equals negative 8. And I'm done with that problem. All right, so now I'm going to do the next problem. All right, well, I know I don't want a 3. I want a 20, so I guess that's my answer. I got to get rid of cubing because I want b to the 20th. All right, so slow it down a little bit. So log base b of 3 to get b to the 20th, excuse me. B to the 20th is equal to x. Okay, so that means I'm putting this value on top of 3, b to the 3, in order to get b to the 20. Well, I hope you can see where my answer 20 over 3 comes from. that multiplication has to equal that value. So I get rid of the 3 and I bring in the 20. Done with it. All right, so now we're looking for zeros of minus 3, x minus 5 squared minus 6, I think, equals 0. All right, so I gotta move the 6 over. I gotta divide by -3. I gotta do the inverse of plus minus, so square roots, and minus 5 becomes positive 5, and a negative becomes a positive. This inverse operations. And in my class, you don't have to show me that, oh, x minus 5 squared equals 6. You don't have to write that. I want you thinking. All right, I want you seeing how quickly you can solve equations with inverse operations. We want to get to the point where we're playing quickly. We're in the Premier League, right? And we got to be able to get there. We got a lot of gaps to fill still. All right, so you're going to practice this the rest of the semester. So feel free at the board to do the following. And then this video, I think, is over because I'm up to 45 and I got 10 more problems to do. Do I have time to do it? I don't know. I see the 6, minus 3. I see the minus 2. Okay, and did I have that answer? Maybe I did this too fast. That would be funny. Yes. So I've got plus minus the square root of 2, and I'm bringing a 5 over. Okay, and I don't remember if I, honestly, my memory is shot. So hopefully I did that just preceding it, but hopefully, I'm here, right? All right, so I am trying to get this done before class starts. Okay, and I can ask you what those are as decimals because I'm asking you to memorize root 2. So when you get to your trigonometry, you got a feeling for size. 5 plus or minus 1.41. I'll keep writing it out. Okay, now I got to get the classroom set up, and I guess I'll try to come back tonight, and because I'm going down to Northampton for dinner with a colleague. So I will still try to get back and get you the other part of this test tonight. All right. End the meeting for all.